Hi, this is Chris, and we are taking a look at questions 19 and 20 here in section 3 of SAT Practice Test 4. So for question 19, it says, if xy is the solution to the system of equations above, what is the value of x? And this is a question type that I can guarantee you will see on test day. Systems of equations is very popular, and so it's extremely important for us to know how to solve these. And when it's set up this way, where they don't already have a variable isolated for you, then the ideal way to solve is by using elimination. We want to see if we can eliminate one of these variables. And so you can eliminate your x or your y. In this one, it's probably a little bit easier to eliminate the x because we don't have to multiply both equations by a coefficient, just the top one. What would we multiply this by so that the x's would cancel out? Well, if the bottom equation has a positive 6x, then for it to cancel, we want the top equation to have a negative 6x, which means we need to multiply it by 2. And when you do, just keep in mind that you are, in fact, distributing the 2 to every term in that equation on the left and right side of that equal sign. A lot of people forget that the 2 also distributes to the 20 when they go to multiply it out. But here, as we distribute that 2, we get negative 6x plus 8y equals 40. And in the equation below, we keep that the same. We have 6x plus 3y equals 15. And now, as we combine those, when we add everything together, the negative 6x and the positive 6x cancel out. 8y and 3y will give us 11y, and 40 and 15 gives us 55. So now we have 11y equals 55, and we can divide both sides by 11, which gives us y equals 5. And since the question is asking for the value of x, in order to solve for that, we can take that value of y and plug it back into either of the equations above. So I think that bottom equation is a little bit easier since it doesn't have any negative coefficients. So when we plug that in, we would get 6x plus 3 times 5 equals 15. And that's 6x plus 15 equals 15. Subtract 15 from both sides, 6x equals 0. And divide by 6, and we get x equals 0 as our answer to number 19. Now let's move over and take a look at number 20. So in this question, it says the mesosphere is the layer of Earth's atmosphere between 50 kilometers and 85 kilometers above Earth's surface. At a distance of 50 kilometers from Earth's surface, so when we're at 50, it says the temperature is negative 5 Celsius. And at a distance of 80 from Earth's surface, the temperature in the mesosphere is negative 80 Celsius. For every additional 10 kilometers from Earth's surface, the temperature in the mesosphere decreases by k degrees, where k is a constant. What is the value of k? So let's see if we can draw a picture of this. So here, when we're at 50, the temperature is negative 5 degrees. And when we're at 80 kilometers, the temperature is negative 80 degrees. So if we're trying to figure out a rate of change in that temperature for every 10 kilometers, let's see if we can figure out the temperature change per kilometer. So we're just going to take the difference for each of these. Here, that's a difference of 75, and here, that's a difference of 30 kilometers. So the temperature change is 75 degrees for every 30 kilometers. And the question's asking us to find this value of k, which is going to be the temperature change, k degrees, per every 10 kilometers. So we can treat this like a proportion. We can cross multiply and solve. When we cross multiply, we get 30k equals 750. To make the math a little easier, you can cancel out a 0. 3k equals 75, and when you divide by 3, you get 25 for k. And that finishes up section 3